I'm Sulgori, and today I'm going to be breaking down solid principles for you. Today we're going to be discussing the following points. What are solid design principles? Why should we use solid design principles? And then we're going to be explaining each solid principle. Okay, so what are solid design principles? Well, solid design principles are a set of guidelines we follow in order to write clean, well-structured, and maintainable code. It was introduced to us by Robert C. Martins, aka Uncle Bob, who has a really famous quote, and that is, "It is not enough for code to work," and I couldn't agree more. So why should we use solid design principles? To get to the point, let's just say solid design principles make a flexible, robust, and maintainable code that is actually a lot easier and more adaptable to changing requirements. So a person would ask me, can we just make it work without following these principles? Well, of course we can, but there's a good chance that in the next release or in the release after that the functionality we're implementing has a change in its requirements. So that person would respond, okay, so how about we implement it now and then refactor or add as we want? To which I'd respond, yeah, but refactoring is very expensive, so why do it? So what we notice here that each letter in solid represents a specific principle. We'll be going through each principle with examples to help you understand them more. Single responsibility principle. A class should have only one reason to change. So if you look at the bad example, we'll find out that here it has two responsibilities. One is to save the user data to the database, and the other is that it sends email notifications to other users. Well, in the good example, we have a class called user that is only responsible for the user data, and we have a class called user database, which is responsible for any relation with the database and the user. So it's responsible for saving the user data to the database, it's responsible for retrieving it from the database, and so on. And we also have a class called user notifier, and this class is responsible for sending and receiving email notifications and so on. So here we find that in the good example, the code is actually cohesive and is easier to maintain and more scalable. So if you want to change how the data is saved in our database or anything related to the database, we only have to focus on the class called user database. If we want to change how the email notifications are going to be sent, we only focus on the user notifier. So each class is only responsible for one thing, and that's single responsibility. The open-closed principle, which actually means that we can extend our software entity, but without modifying its source code. So it's open for extension, but closed for modification. So in the bad example we find that we have a function called process payment, and we can pay in various ways, for example, credit card, PayPal, and so on. In this example, payment processor is actually a small class, but we could have cases that it's a big, huge class, and we'll have to start understanding each part in the class. And when we add a payment method, we'll have to go back to process payment and add this method. So here we're modifying, which introduces tight coupling. So a good way to follow the open-closed principle is using the payment strategy. It's a good example. So here we have payment strategy that has a pure virtual function called pay that any base class uses has to implement. So that way we're actually extending its functionality. So any base class that inherits from payment strategy can implement its own pay without changing the base class. So here we have the credit card strategy, which inherits from the payment strategy and has its own way of paying. And then we have the PayPal strategy that also inherits from the payment strategy and has its own specific way of paying. And then we have the payment processor class, which we talked about before. All we have to do now is just set the payment strategy, and in each payment strategy, it all has its specific way of paying. So now if we're going to, for example, add a new method of paying, all we have to do is make a class called whatever strategy that inherits from payment strategy and has its own way of paying, and that's it. So this way, we didn't change in the payment processor, and we actually just added. There's no modifications in the original source code that happened. So here we just achieved the open-closed principle. Liskow's substitution principle. Simply explaining this, any subclass that replaces the superclass should not cause unexpected behavior. So in our bad example, we have a bird, and we have a function in it that is pure virtual that is called fly. So here we're saying that any bird has to fly. So this is not true because we have a class called eagle. It can fly, yes, but another class called ostrich, it cannot fly. So this is a problem. This causes unexpected behavior. So in the good example, we made a more generalized class called bird, and we have birds that can't fly and birds that can fly. So there's a class called flying birds that inherits from bird, and it has a function called fly. And then we have eagles, a class called eagle, where eagles can fly. So this makes more sense. We can replace eagle with flying birds, and we can replace eagle with actually birds because it's still a bird. The same could be said for ostrich. Ostrich here is no longer a flying bird. It is only a bird. So here we're adhering to Liskow's substitution principle. The interface segregation principle. In simple terms, a class should not be required to implement methods it does not need. So in the bad example, we have a class called worker, where every worker must work and must eat. Well, this makes sense for man worker, because a man does work and does eat. But for robot worker, well, this doesn't make sense because a robot does work, yes, but it does not eat. So class robot worker had to implement eat, even though it doesn't need to. So in the good example, what we did is we took the class called worker and we split it into two interfaces. A class called worker that only has the work pure virtual function, and a class called feedable that has the eat pure virtual function. So now man worker can inherit from both and implement work and eat, and robot worker now can only inherit from worker and doesn't write the work function obvious and doesn't need to write the eat function. So now it does not need to write methods it does not need. And finally, we have the dependency inversion principle, where it states that high-level modules should not depend upon low-level modules. Both should depend upon abstractions. In simpler terms, it means that you should depend upon interfaces or abstract classes rather than concrete implementations. Well, this helps in reducing the coupling between classes and makes the code more flexible, scalable, and maintainable. So in the bad example, we have notification service, which sends notifications. And the only way it does that here is by email. And it directly depends on email service class. So for example, if we are going to extend this and we want to send by SMS, we're going to have to modify the notification service class and have to handle all the other changes that come with it. In the good example, we solved this by adhering to the dependency inversion principle. This was done by the abstract interface class called message service. We introduced message service, which defines the method called send message. Now we have email service and SMS service that both implement the message service interface. And we have notification service that also depends on the message service interface rather than a concrete class. So now notification service can work with any implementation of message service. So it can send a notification by email, it could send a notification by SMS, and we can extend it more and more and more. Very simple. So That way, we promoted flexibility and decoupling simply by following dependency inversion principle. I hope I was helpful and you learned something today. If so, please let me know to make my day. Thank you.